I still hear a bit of a hum, and I'm not sure exactly where it's coming from now because the lawnmower has stopped. So I don't know. I hope it's not too annoying. Just to reaffirm this gyre flow from a different viewpoint and the relation to geostrophy. Let's look at this figure, very nice. So northeast trades in the tropics are pushing water westward. Coriolis is pushing to the north. Coriolis is weaker in the tropics compared to the mid-latitudes where the westerly winds are pushing the water eastward. So you have water piling up in the middle because Coriolis is pushing south in the eastward flowing current and north in the westward flowing current. So you can see here that you have pressure gradient force acting towards the middle and Coriolis force acting towards the middle and creating a geostrophic flow. So you can look at it from a top view where you have a pile of water. You're looking at it from the top, and water is going to want to go downhill all around this mound of water. Okay, and the water as it's flowing down is going to be tilted to the right by Coriolis. So you have gravitational force pushing it down, Coriolis going the other direction and balancing, assuming friction is very small, which in general it is. Unlike the motion on a, let's say I have a cup on the desk, I'm pushing it or anything like that, the friction in the atmosphere and ocean act very differently. It's not the molecular friction that's so important. Okay, we won't get into details, but when the flows are at such large scale, the ultimate energy dissipation happens by slightly different mechanisms than these small scale things that we are used to. So just remember that. So in general, let's say here friction is not that important, even though, as I said, to transfer the momentum from the winds to the ocean, friction was very important. So you end up creating this circular flow around the subtropical high in the ocean. There was a subtropical high pressure in the atmosphere, and there is a subtropical pile of water in the ocean. So around this pile of water you have this geostrophic flow. Is the pile of water symmetric? It shouldn't be, right? So we are saying the Coriolis is stronger at the mid-latitudes where eastward flow is happening, and it's weaker in the tropics where the westward flow is happening. So the pile is asymmetric in the north-south as well as in the east-west. We will see that when we look at more detail. So we are slowly inching towards the concept of creating the subtropical gyre flow in the ocean and explaining why the two boundary currents have to be very different in the ocean. You have to have boundary currents because the ocean water cannot climb over to land, so it has to go along the boundaries. And there are again reasons why Coriolis creates a very strong asymmetry in the west and the east.